All right, so welcome to our lesson today. I'm just going to continue to teach and review and practice slope with you guys. So we're just kind of extending our lesson from yesterday, which was lesson 15, 16 combined. I figured I could combine it, but I think that we need a little bit more practice. So we're going to continue to practice today, working on the same standards, EE5 and EE6. By the end of this lesson, you're going to be able to apply those two different strategies again to find slope. You'll know you're successful when you can use the rise over run strategy and the formula for slope y2 take away y1 over x2 take away y1. We're going to do some review, examples, exercises, close your next ticket, and as always, please keep in mind our class expectations and follow those accordingly. All right, just to review what we've learned yesterday, the slope of a line is the steepness of the line, okay? Slope is increasing or decreasing at a constant rate, and we've learned about constant rate all throughout 7th grade, and we're starting to apply that in 8th grade to graphs. So the first thing you need to do when you're looking for the slope of a line, no matter what strategy you're going to use, is you're going to look for points. And so yesterday we had a little bit of struggle with actually even identifying these points. So the point has to be on this line that's drawn across our page, so I'll highlight it in green. Our point has to be on this line because this is the line we're finding the slope of, and it has to hit where exactly the crosshairs of our coordinate grid cross over it. So I can see right here, here is a section where the crosshairs cross exactly over this line. It makes a perfect little spot. So this is one of the points that I'm going to choose. All right. And if I zoom back out, I'll look for another spot. I'm going down this line, going down this line. Oh, I see another spot right here where these crosshairs hit. So here is another point for me. And to find the slope of a line, you only need 2 points. You do not need more than 2. You can always, try a different point as well and check your work, but it's completely unnecessary. So when we find these points, we're going to write them out. When we write our coordinate points, we always do x, then y. Just like the alphabet, x comes first in our points when we write them. So the first point, I'm going to go find it on my grid. You do your x value first, so I'm looking at this x-axis and see where on this x-axis does it lie. Well, it lies right here at -6. So this is at -6. And then where on my y-axis does this lie? Well, it lies right here at 5. And should you ever get a graph where you don't have these numbers already drawn up for you, all you have to do is just use these little bumps to find them, and I'll do that with my next one right here. So the next point, I see I am at -1, -2, -3 for my x, and then for my y, I'm going up 1. So I found these 2 points, and I know exactly where they're located on my coordinate grid. The next thing I'm going to do is I'm going to ask myself, okay, to get from one point to the next point, what do I do? And specifically, I'm trying to ask myself, what is the rise and what is the run? So slope is the same as our rise over our run. And our rise is essentially how many spaces are we going up or down? And then it's divided by, or it's over, how many spaces are we going over to get to our next point. Now, the first point that we always want to start with is the one that is furthest left on our coordinate grid. So the one that is further left on our coordinate grid is this point right here. So I'm saying, okay, to go from that point to this point, how many do I rise? Well, I don't rise. I'm going down. But as you can see in my little drawing right here, you can go up or down. If you go down, your slope is going to be negative. So I'm going down, negative. I'm going down 1 space, 2 space, 3 space, 4 spaces, and it looks like my point's going to be on that line. So I'm going down 4, and then I'm going to find my run. How many am I going over, side to side? Well, from that spot that I just stopped at, I'm going to go over 1, over 2, over 3. So this is my slope, and I've just found it with my first strategy, rise over run. You're literally just going to count spaces, all right, to get to your next point. And you'll see that this exact fraction, this exact slope is going to be used every single time to get to my next point. So if I start at this point right here, and I'm trying to find my next point, I'm going to go down 4, 1, 2, 3, 4, over 3. 1, 2, 3. You'll see I hit it right on that line. Down 4, 1, 2, 3, 4, over 3. 1, 2, 3. And it is going to work every time because this line is a constant rate. It has a constant slope. Okay, so this is the first way we learned how to find slope yesterday. The second way we learned was a strategy we would use if we did not have a graph or if our point values were, fractions, decimals, not super clear on those crosshairs. So I have -6.5 and -3.1. I'm going to use these points in my formula. So my formula for slope is y2 take away y1 over x2 take away x1. Now this is my first point that I found, and this is my second. So I'm just going to call these my y1, my x1s, and my y1s, my x2s, and my y2s. So this would be x1, y1, this would be x2, y2. All right, and I'm going to use those values to plug into my formula. So my y2 was this 1, so I'm going to do 1 take away my y1, which was this 5. So it's 1 take away 5 over x2. Here's my x2, -3, take away x1, -6. And from there, I can just mathematically solve this. 1 take away 5, that's going to be -4. -3 minus -6. Well, this is a double negative, so I'm going to do keep, change, opposite. -3 plus +6. This gives me the number 3, and that is exactly the slope that I got using my other method as well. So these are the two things we're going to be continuing to practice today: finding slope using rise over run, and finding slope using our slope formula. All right, here's your first example for today, and I'm just going to go as quickly as possible. For the first step, you're going to choose 2 points. I'm going to pause my video and do that for you. All right, so you can see on the graph that I have identified that there's 4 points here, and I'm just going to choose any random 2 points that I would like. So I'm going to choose the first one I saw, -2.5, and 0.2. So these are the points that I'm using, -2.5 and 0.2. All right? The second step is to go from my left point, which is this one right here, to my right point, which is this one down here on the y-axis. I want to find my rise. And this tells me how many am I going up or down. Well, it looks like I'm going to be going down to get from this left point to this right point, so I'm going to be going down 1, 2, 3 to get on this line that this point is on. So I'm going to go down 3. I call that -3. All right? The second thing we're going to do the third thing we're going to do, step 3, is we're going to find the run. And this tells us how many do we need to go side to side. So to get to the second point that I'm trying to reach, I need to go over 1, 2, and then I hit it. So my run was over 2. And these are fractions because our rise over run strategy is a fraction. We do the rise over the run. I look at this fraction, and it cannot be reduced. So I know that my slope for this line is down 3 over 2, down 3 over 2, and it's always going to work. Watch, down 1, 2, 3, over 1, 2, hit the point. Down 1, 2, 3, over 1, 2, hit the point, and we're done here with this example. All right, go ahead and show you how to do example 2. You can see I've already gone ahead and plotted all the different points on this line, so I'm just going to choose 2 of them. I'm just going to choose this one right here, where this is over 3 and it's up none. So it's over 3 with my x and it's up 0 on my y. And then I'm going to choose this one that's right above it. This one's over 4 on my x and up 1 on my y. So looking at those 2 points, I am now going to do step 2, where I'm trying to find the rise. To go from my left point to my right point, how many am I going to go up or down? Well, I'm going to go up 1 space because now I'm on this line where this other point is. So I went up 1. Second thing I'm going to do is find my run, which is how many do I go over. So now that I'm at this little dot, this blue dot, I need to go over 1 space to get to my next point. So 1 over 1. My slope for this was just 1 over 1. Does this reduce? Yeah, 1 over 1 is the same as 1 divided by 1. So this is the same as saying the slope equals 1. And let's see if that's true. If we were going from any point on this graph to the next point, starting with the left to the right, I go up 1 over 1, up 1 over 1, up 1 over 1. It's just like a perfect staircase, up 1 over 1. So that is my slope for example 2. The last example that I'm going to give to you today is an example using the slope formula. So you can see we do not have a graph here, so we cannot use that counting method. We could definitely draw out a graph and then count, but it just would take too long when we know we can use the formula for slope. So the first step in this example is that I need to write out my formula for slope. So this is something you're going to have to memorize eventually, so I want you to write it out every time today when you're doing these questions. M equals y2, take away y1, over x2, take away x1. So this is my step 1, writing the formula. Now, so step 2, I'm going to identify my x1, x2, y2, y1. So looking at my question up here, it says, what's the slope of a line through -7, -8, and 0, 4? So I'm just going to say, okay, well, this is my x1, this is my y1. This is my x2, this is my y2. And now that I've identified those, I'm going to move on to step 3, where I'm just going to plug those numbers into my formula. So the first thing I'm looking for is y2. Well, here was my y2. It was a 4, so I'm starting with 4. Okay? Minus y1. My y1 was a -8. And I'm done with my top. On the bottom, I have x2. Here is my x2. 0. Minus x1, -7. All right. I've plugged my values into my equation, so step 4 is to just solve and simplify. So I'm just going to go ahead and do this math out. On the top, 4 take away -8. That's a double negative. So I'm going to do keep, change, opposite. 4 plus 8 is 12. Okay. On the bottom, I also have a double negative. 0 take away -7 becomes 0 plus +7, which is 7. So the slope for this line is 12 over 7. I don't think that can be reduced. It can be turned into a decimal or a mixed number, but as I'm looking at my answer choices, this is an answer choice. It is C. All right? All right, please take 5 minutes to complete exercise 1 before we go over it. Step 1, choose 2 points. Step 2, find the rise, then find the run, and then find the rise over the run. Divide those two things out and actually tell me what your slope is. 5 minutes starts now. All right, for step 1, you'll notice that there were only 2 points actually on this graph. If you look really closely, this is not like hitting exactly on that line. Where else? This one's not hitting exactly on those crosshairs. So you only had 2 points that actually hit on those crosshairs in this point right here at the top. This is at -3, +4. This one over here is at I did my y first on accident. This is at +1 on my x, and then -3 on my y. All right, so I did step 1. Step 2, you were supposed to find the rise. So going from your left to your right. Are we going up or down? Well, we're going to go down. We're going to go down 1, 2, 3, 4, 5, 6, 7, and this is the line that this is on. So we went down 7, so it's -7. Okay, done with my rise. I'm now going to find my run. How many do I need to go over? Well, now I need to go over 1, 2, 3, 4 spaces to hit my next point. So I went over 4. So my slope for this line was -7, or down 7, and then over 4. And this represents my down 7. This represents my over 4. Okay, hopefully you were able to get this correct. All right, for your second exercise, you're also going to have 5 minutes to do. It says, what's the slope of the line through -1, 8, and 3, -4? You do not have a graph, so you're going to have to use this formula. Your steps are off to the side. If you do not remember the formula for slope, I've gone ahead and written it down here, and you can just use this as a reference to help you out. But please identify your x1, x2, y2, and y1 from these 2 points up here. Plug in your values, and then solve and simplify, and we'll go over pretty soon. All right. Now to go over this question, the first thing you needed to do was identify your y2, your x2, etc. So this was my x1, my y1. This is my x2, my y2. So I'm going to go ahead and use these to plug into my equation. So I have negative 4 as my y2 minus y1, 8, over 3 as my x2 minus negative 1. Okay, the last step here is to actually just go through and solve this out. Negative 4 take away 8. Well, that's the same as saying keep, change, opposite. That's the same as saying negative 4 plus negative 8. So if I'm already at negative 4 and I go back another 8, I'm at negative 12. Okay? On the bottom, 3 take away negative 1. That's a double negative. So I'm going to do keep, change, opposite. 3 plus 1 is 4. Now I have negative 12 fourths as my answer. However, that's not one of my answer choices off to the right, so I know I can simplify this. So negative 12 divided by 4 is what this means. Negative 12 over 4 is the same as negative 12 divided by 4. Negative 12 divided by 4 is negative 3. And that is one of my answer choices. That was choice B. Check your work with mine. See if you're feeling good about this. You're about to move on, okay? All right, for your first exit ticket question today, you're going to be doing exactly what we did earlier. Find 2 points, find the rise, the run, and then calculate rise over run for your slope. For your second exit ticket question, you're going to be finding the slope using your slope formula. So throughout the lesson, we've written this down, so if you need to go back to your notes and see what you wrote down as that formula, please do. But you have 2 points they've given you, and you're going to use that formula to find the slope. All right.